Yes, class. Am I audible to you, Fadil and Shahid?
Yes, ma'am.
All right. So yes, we have to start with magnetic effects of electrical current, magnetic effects of electric current. Now see, some portions we have already discussed in the class. The questions which we have not discussed, we have to discuss them over here. Now, regarding magnetics, the first topic that comes is the Biot-Savart's law. So Biot-Savart's law. What is Biot-Savart's law? We have studied that the magnitude of the magnetic field, this is directly proportional to current, directly proportional to current element, that is dl, which we take, directly proportional to sine theta, and inversely proportional to r square. And what is the constant that we put? So constant that we put is mu naught by 4 pi mu naught by 4 pi I dl sine theta divided by r square. This is the formula that we put in. Vector form, I have also told you, vector form also we discuss. In vector form, when we write the same thing as in vector form, so dB becomes equal to mu naught by 4 pi I dl cross r divided by r cube. Fine. See, magnetic field on the axis of current carrying conductor is always zero. This also we have discussed so many questions in the class when we discussed it. If we are taking a point exactly on the axis of the conductor, then because our theta is either 0 degree or it's 180 degree, that's why the magnetic field also becomes zero. So in questions where you have combinations of figures like semicircle is also placed, circle is also placed, a straight wire is also placed, if the point is put on the axis of it, then you will mark it as 0. And remember that magnetic field on the perimeter of circular loop or coil is always minimum. This is just one more point additional. Magnetic field, because these can come in your statement based questions. So magnetic field on the perimeter of circular loop is always minimum. See, it keeps on increasing on the axis. Why? Because why is this minimum? Because when you talk about here it becomes maximum. Whenever we have the equation for the magnetic field at axis, then it decreases, here it decreases, then this also decreases till the periphery, till this point and this point. And when we go from the periphery to the center, it further decreases. Fine, this decreases. Now, when we are talking about the magnetic field, this is from the axis, now coming from the center point. If at the center, yes, what is the magnetic field at the center of a circular coil?
Mu naught I by 2r.
Mu naught I by 2r. Yes, very good. So at the center is mu naught I by 2r. So this is the maximum over here. Again, when you will go towards the periphery, this will decrease. This will be the minimum. This will have a very minimum value of it. Why this is important? This is not important for your numericals. Nowhere in the numericals you will be needing it, but in your question, statement-based questions, some things are asked which are additional. One more thing, that who discovered, one question that also came in a long time back in the previous years, it is mentioned regarding magnetic field lines. Magnetic field lines. Who discovered it? Any idea who discovered the magnetic field lines? Faraday. Michael Faraday. Faraday discovered them. Why this came? Because see, Faraday's contribution has been mentioned in your NCERT also. All right. Then one more thing before we begin with the numericals that you have to remember is that regarding the magnetic field lines. We discussed many things about electric field lines. Similarly, you have to understand magnetic field lines also. So magnetic field lines are also closed curves. This is no doubt. Why are they are not open curves? They are closed curve. You know that if this is a bar magnet, north, south is being mentioned. Then from north towards the south, the field lines go outwards, and from south to inwards north, the field lines move within it. So they are always closed. Figures will be given to you. Out of all the 4 options, you have to identify them. All right. Then when you drop a tangent on it, if you are dropping a tangent on electric field line, that will give you magnetic field line that gives the direction of magnetic field. This is what you have to remember. And yes, the general representations of the magnetic field lines, how they have come in your exams. If the magnitude is not constant, like this, it will show you. Somewhere the lines are greater, somewhere the lines are shorter, somewhere the gaps are maintained. This is magnitude is not constant. Though this is not very important, this you will be able to manage by yourself. This is not difficult to identify, but let us discuss. This is in non-uniform field I'm talking. Or the field lines can be this also. Somewhere in questions you will see field lines are this. This means direction is not constant. And if both of the things are occurring, this means magnitude and direction both are not constant. Both magnitude and direction are not constant, right? And if they have to show that both the magnitude and both the magnitudes and directions are constant, this will give you equidistant. The field lines are going to be equidistant and straight. If this is uniform magnetic field, then field lines will be equidistant and straight. This is what you have to remember. Then apart from this right-hand thumb rule, we have already discussed in the class. Right-hand thumb rule will be there. But the right-hand thumb rule is particularly for the direction purpose, you already know. Now coming to the applications of it, applications we'll do through questions because good questions are based on application. First, make the note points. Just make a note. Certain extra points which are not included in your class.
Excuse me, ma'am.
Yes, Fadil, say.
Ma'am, do you have separate recordings for the JEE classes? Because this is my first class.
Yes, we have the recordings. All the 3
Okay.
lessons we have completed. So in your batch, we have to start with the next lesson, no? Second one.
Yeah, we have to start with the second lesson.
Yes. So current electricity, magnetics entire has been this. Okay, Fadil. Then take the recordings. Yes. Do take the recordings. And
Okay,
see,
ma'am.
these classes will be slow. So by the time, just have a little patience for the initial classes. And by that time, in your batch, the syllabus will be covered. Because I
Okay.
don't know whether you are informed or not, but you will be having extra classes on Friday. You, not Shahid. Fadil,
Yeah,
I'm
ma'am.
talking to you. Okay.
Yes,
So
ma'am.
it can happen that most portions are completed, because if I start teaching the basics of CBSE here, then we'll not be able to do the JEE part, right? So whatever
Right.
has been completed in the batch, after this we start. So what you do, Fadil, take the recordings and see here I'll be going slow. The class duration is also not very long. 1 hour class I take because the extra portions which have not been discussed that we discuss over here. The difficult questions which involve integration which you will not be able to solve by yourself, or the easy questions also that have been repeatedly coming in the exams. So for that,
Okay.
take the recordings. By next Wednesday or next to next Wednesday, 2 weeks we'll have. So most probably second lesson will also be towards the end. So let's see how we go about, or if you have a particular doubt, then let me know within the class. The
Okay.
entire topic I'll not be able to repeat, but if you are able to manage for the time being, just pay attention to the class. Once this is done, once the topic is also done, you'll be able to pop up over here also. This lesson will take a little time because chapter 5th and chapter 4th, this I am doing it together in this
Mm.
batch. Okay.
Okay, ma'am.
Now, the questions that come in your JEE exam from magnetics are basically the application of Biot-Savart's law. Father, in your school, I hope you have some idea of this lesson.
Somewhat, ma'am.
Somewhat. Okay, then I'll share the recordings with you then. At least
Yeah, ma'am.
till the time what you can do for the lessons that have been missed also. Because in your batch, we are currently doing the first, at least for the first lesson completed by this weekend. Because on Friday, most probably this Friday, or during the weekend, you already have your class. All right.
Yes, ma'am. Saturday we have class.
Saturday. See, application of Biot-Savart's law. Father, let me brief you with Biot-Savart's law. Biot-Savart's law, basically we have, if a current element is present, current is moving on, a small element that we take, when we cut the portion, this is known as DL. DL we take, this we call as the current element. So its formula becomes mu naught by 4 pi I dl sine theta divided by r square. Now what is this? R is the separation. Suppose I have a point. This is a current carrying conductor. And at this point, I am asking you to calculate magnetic field. Now, how will you calculate? So mu naught by 4 pi is a similar constant to 1 over 4 pi epsilon naught. This we put. Then we write I. I is the current that is flowing across it. And then we talk about DL. DL is the current element. That is a small portion of the wire. If I cut it, that is the small portion of the wire. So I mu naught by 4 pi, this is the constant. I is the current. DL is the current element. At least you'll have a basic knowledge of this. So you will be able to relate the upcoming part. And then see, there will be a separation to this point of calculation. I have just given you a random point P, but there must be a certain separation. So this is R, right? So this becomes R squared, that is separation. Separation, or you can say position vector. The way in Coulomb's law, we take R square, magnetic field is inversely proportional to R square. So this is position vector, right? And see, now this DL is making some angle. If you look here carefully, this DL, this is making some angle over here. This is theta. So this is directly proportional to this sine theta. This is the angle that the current element is making with the position vector. This is what is your Biot-Savart's law. In your class, we'll discuss it in detail. So you will be doing this in detail, everything. Right now, I'm just briefing you. Now coming to the calculation part. Among the application of Biot-Savart law, among the application of Biot-Savart's law, suppose this is a finite conductor. This is a finite conductor. A, B, these are the point. It's a finite conductor. And I have given you a point P over here to calculate. This is the point P I have given you calculate. And this is fixed. This is finite. So see, this must be subtending a certain angle. If we look it from here, this must be from this end, this must be subtending some angle to this point. From this part also, it must be subtending some angle. So this I am counting this as theta 1. And this I am taking it as theta 2. This is what type of device am I taking? The first case, this is a finite conductor. When I say finite conductor means the ends are fixed. If this is one end, this is another end, this separation is definite. This separation is definite. Like if it is 5 meters, it will remain 5 meters. You cannot change it. It's not variable. All right. Now, what is the formula of magnetic field over here? Magnetic field at now this point P. Because see, how will you apply Biot-Savart law? After certain derivations, see certain derivations, only those derivations I'll discuss in this batch, and I have been discussing those with Shahid only, which are of significance importance in the formula part also. Like if I give you a numerical, that derivation might help you, then only we discuss that. Otherwise, other derivations which are important for your CBSE will be discussed in your respective CBSE batches. And rest of the derivation, like this finite derivation, finite conductor. Earlier, 4 or 5 years back, this was included as the derivation. Now this is completely deleted. Finite conductors deleted from your CBSE, no need in your JEE exam. So we won't be discussing it. What is the formula? If the current that is flowing through this is I, fine. This is the separation. Let's say the separation, this is A. So formula of magnetic field becomes mu naught by 4 pi. Constant is there. Mu naught by 4 pi. I by A. All right. Now, sine theta 1 plus sine theta. This is the formula. Now, depending upon different types of cases, you will get different types of formulas. One question was there regarding infinite length. This was finite, which we discussed. If we talk about infinite lengthened conductor. Now see, when I'm talking about infinitely lengthened conductor, for infinitely, this means this is extending from plus infinity to minus infinity. Now, again, I have given you a point P for calculation. I have again given you point P for calculation. Now see, when we have infinite ends, so now what we do? If the infinite ends are present, earlier in the previous example, I had taken this as theta 1, this as theta 2, because these were finite ends. We can touch these points. No, A point is rigid. This is fixed over here. This is fixed over here. Now what? Now these ends are extending up to infinity. See, if this is a boundary, just listen here carefully. If this is a boundary, fine. This is a point I have taken. You can see this. Now I have extended this. So the angle becomes this theta. All right. Now I am extending this further. This becomes greater. I am extending this further. Can you notice? Theta is becoming greater. Again, I am extending this further. This is becoming even greater. If this is to infinity, when I'll extend this, extending, at the point of intersection, this will appear like this. At the point of intersection, once I'm extending it to infinity, it will appear like this. Somewhere extending towards infinity, the points are actually even not meeting. But this is our final intersection at infinity. Right? And when you're extending. So the angle that we take over here, this becomes 90 degrees. That's what I'm trying. the angle that we take, this becomes 90 degree over here. Because the ends are so huge, the ends are at such a big separation that you cannot calculate it. So you will take, if you are, even if I'm taking this as a particular end, this I'm taking. So finally at the last, this angle, this is separation A, the current is I, this angle theta 1, this was angle theta 2. Extending, 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 extending. This becomes 90 degree, this becomes 90 degree. Now coming back to our formula. This formula was B is equal to mu naught I by 4 pi A sine 90 degree plus sine 90 degree. So this becomes mu naught I by 4 pi A. This is 1 plus 1, that is 2. So finally, magnetic field, this is going to be, see that 2 and 2, this 2 will be cancelled. This is 2 mu naught I by 4 pi A. So formula for infinitely lengthened conductor, this becomes mu naught I by 2 pi. Coming to one more part, then you can note it down, or just note it down, then we discuss. Written till here?
Yes.
See, two more cases I'll discuss, then I'll leave you people. Third case is semi-infinite with point not at finite end. So this means what? Suppose semi-infinite, I hope you people understand, means one end is pointing towards infinity, other end is fixed. This is rigid. Now this case is not included in your CBSE. So here only we'll be doing it. See, suppose I have given point P over here. Semi-infinite wire means these ends are extending up to infinity, but this is finite. This is fixed. Now the point is not at finite end, means the point is somewhere here. So now what will happen? This separation, this is not meeting the finite end. This point, this is not meeting the finite end. So again, see this, when you will extend from this side, this angle, this is θ1. And now you will be extending this. This is finite. So you will get some θ2 value. This is extending. This is going to infinity. Again, you have current I that is moving. Separation is A. Now coming to magnetic field. B was equal to mu naught I by 4 pi A sine θ1 plus sine θ2. Sine θ1 plus sine θ2. So when you put θ1 will be extending and becoming 90 degree, right? But θ2 is fixed, θ2 is rigid, it can be any value. So we are just putting it as theta. So this becomes mu naught I by 4 pi A. And this sine 90, this becomes 1. So this becomes sine θ plus 1. This is not included in CBSE because in CBSE you just have towards the finite point, last end. And coming to the final one, this is we have discussed already in the class, semi-infinite wire. Now point is towards the finite end. See, this is extending up to infinity. Point is located over here. Current I is flowing, separation is still A. Now the second angle, θ1 that we consider, this will be 90 degree, but θ2 becomes 0 degree. That's why the value becomes mu naught I divided by 4 pi D. That's it. Because this is 1. 1 plus 0 is 1. So you are left with this. Note down these two cases as well.